Good morning to you all, and welcome to today's webinar for the K+S Brine Challenge, brought to you by NineSigma. My name is Jonathan Yakasha from NineSigma, and I'll be your host and moderator today. Please note that this webinar is being recorded. The recording and transcription will be made available on the K+S Brine Challenge page. Let's review our agenda for today. After I introduce our speakers, they will discuss the project in greater depth. Then we'll take some time addressing your questions during a live Q&A, followed by a brief summary of project information, including how to request additional information or assistance. As we proceed through today's presentation, please feel free to ask questions at any time. We'll keep track of your questions and respond to them during the Q&A portion of the webinar. Should you need any additional information or assistance outside of today's webinar, please contact the NineSigma Provider Help Desk at phd@ninesigma.com. Don't worry if you didn't catch that email. I'll have that information again for you later on in today's presentation. At this time, I'd like to introduce our panelists for today. First, from K+S, we're joined by the following gentlemen: Arne Schmeisky, Michael Pura, Serak Rezan, Michelle Wudowning, Benedict Kalpen. And from NineSigma, we're joined by Jos Senens. Gentlemen, thank you all for joining us today. First up, from K+S, Michelle Wudowning. Michelle, would you please give our attendees an overview of K+S?
Yes, thank you. Welcome, everybody, to today's webinar on the Brine Challenge. I have the pleasure to tell you something about our company, the K+S Group. As you may know, K+S is an international resources company. We have about 15,000 employees around the world. The company is headquartered in Germany, but we operate many production sites in Europe, in other regions like North and South America, and we have a worldwide sales network. Basically, K+S produces two commodities, that's potash and salt. And this is also where the name comes from, K+S. K is the German word for potash, it's Kali, and the S stands for salz, and it's in English salt, so K+S. In the potash business, we are among the top providers worldwide with a market share of about 10%. And in the salt business, we are the largest producer globally. Our main products are potash fertilizers, especially potassium chloride or MOP, but also specialties fertilizers. And the salt business, we produce de-icing salt, salt for chemical and industrial salt. And our most famous brand in the consumer salt business is Morton Salt. In the US, you may have heard about it. The Umbrella Girl is a very famous icon there. Next slide, please. We come back to potash. We operate one potash site in Canada in the province of Saskatchewan. It's a pretty new one. We started production there in June 2017. And we operate 7 potash plants in Germany. You see them here on the slide. They're all over Germany. And the biggest potash site is the Werra plant, which has actually 3 sub-sites, Wintershall, Unterbreitsbach, and Hattorf. This is the biggest potash plant we operate with about a bit less than 50% of our production capacity. Some of the German mines are pretty old, some about 100 years old. And when you mine potash in Germany, you always have to deal with solid and liquid tailings. And my colleague Arne Schmeisky now will explain that to you more in detail. Arne, please.
Thank you. Next slide, please. Welcome to our K+S Brine Challenge. And as Michael already said, I want to talk a little bit about the general problem or the challenge that we're talking about. And as he just mentioned, we're a mining company, and when mining potash, you have to consider that the raw material we mine only has a limited share of valuable resources, so only about 30% of what we get out of the mine is actually a product that we can sell. So we have quite a lot of tailings And that's a problem that all potash producing companies in the world face. And the problem is that the reutilization of these tailings is not possible for the whole amount. So what we have to do is we have to dispose our tailings, and one way is, as you can see in the picture below on the left side, are our tailings piles. Partly the solid tailings are also brought underground, which is backfilling of the excavation voids within the mine, but this is not possible for the whole share of tailings. So it's inevitable to create tailings piles. And piling is a technology that's been used for decades, and which is also called the current best available technique. So this is done at all mining sites where potash is generated. And you also have, besides solid tailings, you also have liquid tailings, which we have to dispose. And this is usually done via two different ways. One is the injection into surface water bodies. In our case, this is a river, or via deep well injection. But today we want to focus on the tailings piles. And in the next slide, you can see how brine is generated. So this is actually really simple. You have a large mountain of salt, and as soon as it starts to rain, the rain will just dissolve the salt and brine is generated. And as you can see in this picture, we have a tailings pile with a basal structure to avoid as much as possible that these brines percolate within the underground. And we're collecting those brines in ditches. And as soon as we have it collected, we need to dispose it, like I said before, by injecting it into rivers, for example. And small amounts will percolate under the basal structure or the base of the tailings pile. But to avoid that, like I said, we have the basal structure. We left that out in the following schemes because we think it's not really important for this challenge. So to cope with this problem, in the next slide, I can briefly show you. The idea is to avoid the brine forming by covering the potash heaps, and this is done by adding some sort of covering material. And the idea is that the rainfall will be stored within this covering material, and then it will be evaporated. This can be done either by vegetation that is also implemented on this layer, or it's also possible to have techniques not using any vegetation. And in the next slides, I would like to present you different techniques that have been developed and are also best available techniques for the covering of potash tailings piles. So in the left, you see direct vegetation. This is a technique that can only be applied on very few, very old tailings piles, because to vegetate it, it requires a certain amount of insoluble parts that will enrich during the brine forming. So if the salt is dissolved, insoluble parts will enrich on the top layer, and it might be possible to grow plants on these layers. But this is only, like I said, this is only possible for very few tailings piles, and our brine challenge focuses on large tailing piles, especially from the Werra site. And there we don't have that amount of insoluble parts. So this is not a technique that can be applied. A second technique that you can see is in the middle, which is called the common covering technique, which is also used for waste dumps, at least close to the techniques used there. And we used this picture. It's just a scheme. Usually you have several layers and several different layers that are applied on the tailings pile, but this scheme is to show you, which is the challenge with the large tailings piles. We cannot really use this technique for large tailings piles because as a covering material for small to medium-sized tailings piles, it's possible to use common soil materials or materials from deconstruction works. But we have a very steep slope from the salt. The salt has a natural slope somewhere in between 35 to 40 degrees. And if you use common soil materials, you do not really get this slope angle. And this will lead, as you can see in this scheme, to a really large land use. And the larger the tailings pile, the larger the land use is. So therefore, we cannot really use this technique at these large tailings piles that we're talking about in our challenge. And K+S developed a technique which is called a thin layer cover, which is depicted on the right side, where we use a conditioned material, where we try to create a material, a soil-like material that can be applied almost hang parallel. This requires a lot of science and also a lot of different materials, and it's hard to figure out how to apply these materials. So this is possible for large tailings piles. This is one of our solutions that we see as a possible, a viable solution to reduce the brine forming. But we're also looking for different techniques and for different ideas, and that's why we started this challenge. And as you can see, this cover is also a vegetative cover, as well as all three of them are used with vegetation. And from the left, the direct vegetation, you have an efficiency of about 30%, which means you will evaporate around about 30% of the rainfall. And the other two techniques have an efficiency of around about 80%. So we can avoid 80% of the rainfall to actually touch the salt, and therefore the brine is reduced. There are two more techniques on the next slide, which do not use vegetative covers. So they are without plants. And one of them is the creation of pond structures, which is only possible at top areas. So you need an even ground to create a pond or a pond-like structure. And the idea is to have plastic liners to catch the rain and then get it off the top as fast as possible. So we are not having a real pond where the water stays, because that would be too dangerous. But we will try to catch the water, and then of course we will avoid 100% of rain touching the salt in this area where the pond is. But like I said, this technique is not applicable to the slope, because you can't have any pond structures in the slope. And the last technique that was also developed by K+S is a non-vegetative cover, where we use the same effect that is used at the direct vegetation, but we will create it artificially. That means we will add up to 5% of insoluble materials to our tailings, and in the final layer of salt there you have 5% of these insoluble materials, which will enrich within the time, and that will create a top layer cover that is able to store the water and evaporate it. And this is more efficient than the pure salt. When we talk about evaporation rates, the pure salt has around about 10%, somewhere in that area, and we will raise that using this technique to around about 50%. And so much to our approaches that we are using right now. Next slide, please. Here's some background information that you will need, or you might need, for your ideas, because we have limiting factors. As I said, we cannot really build any ponds in the slope, but also if we build ponds on the top areas, you can see in the left pictures, as soon as you construct anything on the salt, you will have rain collected, and you will have rain at certain areas, leading to these solving areas. So you create holes within the salt, and this is a problem if you have structures that are non-salt. So you will already see that the ponds are not in a cover that can be applied for the whole time. It's only a temporary cover because it has a high maintenance problem. We always have to take care that these holes don't get too big, so you always have to work with the new salt, fresh salt, and to fill these holes again with salt. So that's something that you should definitely consider, especially by any constructions on the salt. And one second big part that's really a challenge when covering is that we have a viscoplastic behavior of the tailings pile, which means it will loosen height, but it will go to the width. So it'll actually move. The tailings pile is moving, and there are two different structures within the tailings pile. We have a core structure, which is in the center due to pressure and crystallization, we have a higher density in this core structure, and you have a mantle structure where we have not a density of that height. So in the core, it should be somewhere around 2 grams per cubic centimeter, and it's slightly slower in the mantle. So you have different areas, and again, the tailings pile is moving. So if you think about a cover, that means you need to have a certain ability to heal itself, the cover. So the cover cannot be too concrete-like because it will break sooner or later. And I think that's so far all to the background information. In the next slide. So the challenge is how to avoid or minimize these brine formations. And please consider that we're talking about only large potash tailings piles. So like I said, certain techniques are not possible in this area and for these tailings piles. And in case you have any questions, that's what we have the webinar for. Please feel free to ask them. But for now, back to NineSigma.
Great, thank you, Arne. Now we'll turn to Jos Sennens from NineSigma to tell us about the success criteria for this challenge. Jos?
Yes, Jonathan. First I want to say also that the documents describing the whole project are available on our website, so that you can find them on the K+S Brine Challenge page under the Process tab. And also on the forum, we have created a post that is called Resources, and there you have links to all the documents that are relevant to this challenge. Here, as you see, the summary of the success criteria. So as Arne already said, we want to reduce the brine runoff with at least 80%, hopefully more. The solutions should be resistant to weather conditions. They should also be resistant to the movement of the pile that happens over time. And also they should be resistant to salt corrosion and to the abrasive nature of the salt particles. Also important is to consider as much as possible the costs of the materials. Also logistics is important, and any material that is proposed to cover the piles should have no impact on the environment. And of course, they should also be available in the longer time in case you needs to repair some defects that might happen over time. So next slide, please.
Sure. At this time, we're going to go with Michelle Wudonning from K+S. Michelle, could you tell us about the awards that are possible in this challenge?
Information, I guess, what will be the award. So we will pay a minimum of 1 or up to 3 winners a prize, which is 20,000 euros each. So this is a cash prize. So minimum will be 1, 20,000, and up to 3 winners, depending on the proposals that we will get. In addition, we are open for potential joint cooperation project with the challenge winners. The objective of this possible cooperation, of course, is to use the proposed technologies and to develop it for industrial use. That would be, of course, the best case for us. But of course, this would be up to negotiation between K+S and the potential winners.
Very good. Thank you very much. Turning back now to Jos from NineSigma. Jos, could you tell us about some more of the process details of this challenge, the timeline, submission process, that sort of thing?
Yes, here you see the challenge timeline. So you can see that the challenge is already live on our website since September 20th. So at the moment it's live. Very important is the deadline of the challenge. So at December 12th, 2018 at 5 p.m. Eastern time, so that's the time applicable in Cleveland, Ohio, the challenge will be closed. So any proposal that you want to submit, you should submit before 5 o'clock afternoon Eastern time. So please do not wait until the last day to submit your proposal, but try to do it now or at least a few days before. And another date, the proposals will be evaluated in the first quarter of 2019, and we expect that the winners will be announced in the month of April 2019. Next slide, please. This is a submission process slide. So when you click on submit a proposal button on the web page, you will open this page. Here you can fill in all the details that you want to include. You can also upload attachments. You can upload PowerPoint file or a PDF file or even Word files and video files. Also wanted to show you on this page that when you do not finish your proposal in one session, you can save the draft and continue later. There is some confusion sometimes when people want to continue writing on their draft the day after. They sometimes click again on the submit proposal button, but that will just open a new draft. So in case you want to continue working on your draft, you should go to your control center, and there you will find the draft that you are working. Next slide, please.
Great, thank you, Jos. It's now time for the frequently asked questions. These are questions that are either generally asked about NineSigma projects or questions that have already been submitted to the NineSigma provider help desk. Our first question is, what is the main process or technology for heaping up the tailings piles? I think this one will probably be best addressed by the K+S team.
Sure, that's a question we didn't really answer in the background paper, but it's probably really necessary to know, because to construct the heaps or the tailings piles, we use usually conveyor belts. The factories are very close to our tailings piles. So the tailings are brought to the tailings pile via a conveyor belt, and then the heap is constructed with a top to bottom method. So it's just poured over the edge, and therefore it is growing. There are, however, excavators and caterpillars on top of each of the tailings piles in case there needs to be any maintenance done or salt needs to be gotten into some certain directions. So usually we use it using conveyor belts, and this technique is also used for most of our covering techniques. So the thin layer cover, as well as the artificial evaporation cover using conveyor technology.
Very good, thank you. And our next question, why does K+S not use plastic liners to cover the potash tailings piles?
So this is a question we hear quite often, especially now that we say we will build ponds, because the ponds we will build at the top using plastic liners. And of course, this is possible at even ground. But like I already mentioned, the heaps are moving. You have very sharp edges. You have quite a lot of problems with work safety using plastic liners, because we're talking about slope length of a few hundred meters. And there's several other factors that make it almost impossible to use plastic liners. For example, we need to mount them somehow to the salt. So all type of anchor or whatever you will try to get into the salt will be washed out either by water or by condensating water. And also, if you cover the whole tailings pile at once, you will have a huge amount of water. In case you have heavy rainfalls, you will have to cope with real large amounts of water, which is also a problem. Now, as you can see, we have quite a lot of different issues why we cannot use plastic liners, and you can usually always address all the problems one by one, but this will either improve one of the other problems, or as you can see, we cannot solve all the problems at once. And also, we were talking to different producers of plastic liners, and they already said that even they think that this is not possible to cover the slopes with plastic liners. So maybe that's an answer for the question.
Great, thank you very much. It's now time for your questions, attendees. We'll open up our session to your questions. We already have a number of them coming in, and we will get to them momentarily. If you haven't already submitted your question, please feel free to do so via the Q&A chat box. As I said at the beginning, we are collecting all of your questions. If we run out of time today and don't get a chance to answer your questions, don't worry. The questions that you submit during today's webinar will be included with the transcript, so we will get you the information that you are looking for. With that in mind, we'll proceed to our next question. Our next question is, how does the brine collection work, and how do you dispose of the brine? K+S?
I think we mentioned that in the beginning. So the brine collection is done via collecting ditches. So you have ditches all around the tailings pile structure, and the water will be prevented by seeping into the underground by basal structures. And also, like we said in the beginning, we have a core in the tailings pile, and this core is, the water will not go into that core, it will not infiltrate, it will run to the ground within the mantle structure, and then usually come to the basal structure where it will seep to the collecting ditches, and there we usually have ponds to store them, and then we're legally allowed to dispose it or to inject it into the river Werra, which is close by the plant. And we're not allowed to pour in the whole brine at once, but there are certain limits that we will stick to, and therefore one by one we will inject it into the river from these storing ponds.
Okay. Our next question, why are the tailings not used as a product such as de-icing salt?
That's also a question we hear quite often because it seems really obvious, but there's different problems. The quality is too low to directly use it as a de-icing salt, which would be probably the easiest way to use it, because you have not only sodium chloride, but also magnesium chlorides, which would make streets even more slippery. So it would be not very productive using it directly. And using it for any other purposes would require a cleaning, which is highly energy consuming and would be really expensive. So therefore, it is cheaper to mine salt for these uses rather than using the tailings. Also, we have to consider that no one actually needs these huge amounts, because we're talking about millions of tons, and there is just no market to sell all this salt, even if we could clean it to a good price.
Okay, and actually kind of staying with that concept there, Arna, our next question is, can the brine be used for industrial purposes? And I think you've touched on that a little bit. It's a question of the volume and the quality. Is that pretty much accurate?
Yeah, that's pretty much it. So the main problem is that we don't have pure sodium chloride. There's just small amounts of different other salts, other minerals and clay in there, which make it way too expensive to clean it, no matter for what purpose, even for de-icing salts where you don't have that hard regulation. So there's allowed to be a certain amount within that, but even for that, it's not cost effective.
Okay. Our next question kind of goes to using the mine itself. Is the mine suitable for brine disposal or backfilling of the tailings?
So this is actually done where it's possible. So the problem is that when we mine, we have a chessboard-like infrastructure underground. So you always have pillars and rooms in between, and therefore you have a huge infrastructural network underground, which almost has the size. So the roads underground have almost the same size as Munich. And you have really long distances and only small areas where you can put the salt. In some mining areas, it's possible. If you have large excavation voids, you can refill them, but this is also highly cost effective, and therefore it's usually not done.
Okay. All right. And the next question kind of goes to technologies for dealing with the tailings themselves. Why don't you use solar evaporation to dewater the tailings?
So if you think of solar evaporation, which is done to win salt for food grade in coastal areas, you could build large ponds, which we do for storage. But the problem is that we have, in our climate, it's not warm enough. You have too much rain, so using solar evaporation just doesn't work due to the weather conditions we have.
Okay. The next question kind of builds on that a little bit. Are there common desalting techniques applied on the brine solution? If solar evaporation doesn't work, are there other techniques that you use to dewater the brine solution?
So there are quite a lot of techniques known, like reverse osmosis or nanofiltration, which would generally be partly possible. I think reverse osmosis is not even possible because the salt content is too high for this technique. But the problem is that we're talking about several 100,000 of cubic meters of brine solution that we have each year. So it's around about 800,000 cubic meters of brine solution generated at each of the tailings piles. And if you think of any techniques to desalt them, these amounts are usually not possible at a cost-effective level. And also you have to consider that we're looking for a long-term solution. And if you think of desalting, what you would basically do is trying to get the rain out of the salt by creating salt again, which you put back on your tailings pile. And this is basically a never-ending story. So this is not really a long-term solution.
Okay. The next question that we have here goes to some of the covering techniques that you talked about. This particular question is saying, what covering techniques have been tested but that are not currently in use? I think the question is kind of going towards, are there approaches that you have tried and are not interested in at this time?
So we have actually looked at quite a lot of different techniques that might be possible, that would be possible. One, for example, is the plastic liners, which we see not as a viable solution. There have been suggestions, to cover it using solar panels, and like I already said, that's also something that we don't see as a viable solution because we can't really construct anything on the salt. We have considered large roof constructions, which would be technically just not possible. And I think we have quite some other different things that we looked at and have considered and that we've tested, which would probably be a bit time consuming, but maybe we can add a list of different techniques later on in the transcript to give the participants a good idea of what we've considered already.
Okay, very good. Okay, our next question. I'm going to try to interpret it a little bit because they didn't include quite a bit of information. The inquiry is about whether or not it'd be possible to use bioremediation to deal with processing the brine solution. Is that something that you have investigated?
I have to admit that I don't know the word bioremediation.
Basically, the idea is using organisms that can process the brine solution naturally.
Okay, there's usually you don't have any plants or microorganisms that are possible to survive these high salinities that we have. So we don't think that there's a way to desalt the brine using plants or microorganisms because it's just toxic to usually all organisms we know that might be possible for such a technique.
Okay. To build off of that, if somebody were to have a bioremediation solution, be it a plant, be it a microorganism, would that still be of interest?
I guess no. Sorry for the interruption. Because the amounts are just too high. You have the huge amounts of brine and you have the huge amounts of salt, which are generating brine. So it's just the amounts of salt are too high.
Okay.
Of course, we will look into all the ideas and we will check them all because we don't know where you're going, in which direction you're going. And of course, if there are any solutions provided, we will of course look at them and see if we can consider it for any use.
Okay, very good, thank you. Our next question is the desired solution to stop the infiltration through the tailings or, stop the infiltration through tailings only or brine leaching as well?
Sorry, we didn't really get the question.
Sure, no, not a problem at all. I will repeat the question. Is the desired solution to stop the infiltration of rainwater into the tailings themselves exclusively, or are you also interested in technologies that can prevent brine leaching as well? I think out of the tailings pile.
So I don't really get the difference, because all the water that goes in the tailings pile somehow needs to go out somewhere at some point. So we'll try to reduce it. I don't really see a solution where we can have the water stay in the tailings pile, if that's what you're aiming at, but maybe I'm not really getting the question.
Okay, for the individual that submitted that question, if we have misunderstood the intent of your question, please feel free to resubmit it into the Q&A chat box. And if we have time during today's webinar, we'll address that again. With that in mind, we'll move on to our next question. Okay, how can we lower brine discharge levels when discharging down our drains into municipal water treatment plants? I think that question is basically getting at the heart of today's challenge here. They are looking for ways to reduce the brine discharge levels. Would that be an accurate summary, K+S?
Yes. Maybe
Okay.
maybe I can come back to the question before. Maybe when thinking about it, the question might be if the idea is to also avoid getting the brine solution into the underground. So if we're looking for different ways to avoid having any infiltration within the underground, and the answer to that would be no, because we just further developed our basal structure to a new system that will be applied right now. Maybe if this is what the question is aiming, we're not looking for new types of basal structures.
Okay, very good. Okay, our next question, actually we've got a couple of questions that are very similar to this. So this has been a popular area of consideration here. Can you please describe the approximate size, the surface area of the pile, and if possible, the typical concentration of the salt in the brine?
Sure, that's probably one of the most important questions. I'm not sure if we've addressed that at all. I'm very sorry for that. When we're talking about, I'll just give you all the background information I have here with me to the tailings piles. We're talking about an area covered by these tailings piles of around about 86 to 90 hectares at the Hattorf site, which is one of our tailings piles. And at the Wintershall site, we're talking of a covered area of slightly above 100 hectares. About the height that is approved by the authorities, we're talking about an approved height of 520 meters above sea level, which would be for the Hattorf site around about 165 to 230 meters above the ground. And for the Wintershall site, it would be 110 to 260 meters above the ground. We have a large variation in these numbers because the area where the tailings piles are not even. So we have a mountain where the heap is basically at. So the level above ground is not the same at all the places. We are talking about a total volume of 80 million cubic meters at the Hattorf site. So these are only roundabout numbers. So the heaps are still operated and they will still grow. And at the Wintershall site, we talk about a volume of about 107, 110 million cubic meters. We are talking about an amount of 160 million metric tons at the Hattorf site and 215 million tons at the Wintershall site. And we have, like I already said, an amount of brine formed at each of the sites, which is somewhere in between 700 and 900,000 cubic meters of brine solution. And the brine solution has a concentration, a total salt concentration of 330 grams per liter.
Okay. Thank you for that in-depth description of the tailings piles. Our next question, what is the cost of collecting and disposing of the brine solution currently being generated?
I'm afraid we don't have an exact number for that right now here, because I'm looking at faces no one really knows. So we can see if we can figure out these numbers afterwards, but right now I think we cannot answer it. Sorry about that.
Okay, very good. Our next question, we will actually switch now from the K+S team. We have a process-related question for Joost Sennens. the question is asking, what is the difference between the response title and the title of the proposal? Jos?
The response title is the title that you give to your solution. So if you say, I have a new cover, your response title will be new cover to solve the problem of K+S, for example. So a lot of people also use the K+S Brine challenge title in their proposal, but you can write your own title for your proposal to summarize in one sentence the approach you have in mind.
Okay, thank you, Jos. Our next question. In the descriptions, only old tailings have been described. In the case of an ongoing tailing, the building of an ongoing tailing pile, what are the conditions just before being put into the tail and at the end of the process? The question is asking about the temperature, the humidity. I'm assuming they're asking the temperature and the humidity of the material itself and not the atmospheric conditions around the pile itself.
The temperature of the residue would be around 40 degrees, 35 to 40 centigrades, and humidity is about 8 to 10%, depending on the plant and the tailing. So,
okay.
enough information?
I think that gets to the information that they were looking for the person that submitted that question. Likewise to you, if the answer did not describe what you're looking for, please let us know and we'll try to circle back around to that question. Our next question, to avoid large immediate runoffs of rainwater, is it thus necessary for the proposed solution to absorb some rainwater and then allow for slow evaporation?
That's an interesting question because this is what happens at the salt at the moment. So maybe to get to some understanding what's happening now, if it's raining, the water will go into the salt and it will seep through the tailings pile, and that will lead to a really even forming of brine solution. So we almost always have the same amount of brine solution being formed each day. So even if it's heavy raining right now, we don't have much more brine solution forming at that moment. That might be interesting to know. And also for all of our solutions that we have in mind for covering, we always have a certain infiltration and storage rate. So we don't have to cope with huge amounts of fresh water being generated during one heavy rainfall. However, because we don't know your solutions, if you can cope with this big amounts of water, it's probably possible to not necessarily having these abilities.
Okay.
But please consider also that in case you will have a solution that will seal the whole tailings pile, that we have these huge amounts of water being formed at once and that we have to somehow cope with these.
Yes, and we have no wastewater system to catch or collect all those waters.
Okay, thank you, gentlemen. Arne, you touched on this briefly. This question is, how large is the deformation or movement at the foot of the tailings pile?
So this is also a very interesting question because the movement rates are not the same all around the tailings pile. You have areas where you have a larger movement rate, which is only a few centimeters, but in other areas you'll even have meters of movement, and there are different factors that are that actually lead to these formations, which is one of all is the underground. So it depends on how the underground is at that area, and also on how fresh the part was dumped or heaped up. So the short answer would be it's some centimeters to even meters, or 1 meter, 2 meters, around about that.
And vertically and horizontally.
As a corollary to that question, what sort of time scale are the tailings piles changing? I mean, is it over the space of a number of hours? So I mean, the tailing pile moves from where it was at the beginning of the day, or is this a time scale of a couple of days, a week, a month?
No, this is per year, so you have
Per year.
movement rates per year.
Okay, very good. Our next question, what is the maximum cost per ton of rejected salt expected for a solution?
That's a question that's really hard to discuss, because we don't want to focus too much on the cost of your idea or of your solution, because the problem is that the cost might be developed over the years, and we're talking about an ongoing operation of the tailings pile for years or decades, hopefully. And therefore, we see that there might be changes within the prices of whatever your solution is, even if it's a covering material, if it's some sort of chemical solutions. So it's really hard to put a number on that. Therefore, we don't want the participants to focus too much on the costs, because we'll have to consider that individually, depending also on the ideas turned in.
Okay, very good. Another question that I believe you touched on previously, are these tailings piles active? Meaning, is new material continually being added? And I believe you said that they were. Is that correct?
Yeah, that's a big problem. We have running production while you have to cover up the tailings. So there's a huge amount being piled up each year, like around 6 to 7 million tons, while you have to cover the tailings. So you always have to keep that in mind.
Maybe to give you an idea what it looks like, because we're covering one of our larger tailings piles right now at the Sigmundshall site close to Hannover. And this is done by the heap being operated at one end. So the heap is basically growing into one direction, and from the other end you will start heaping up the covering material. So this is possible. It's possible to have, for example, two different conveyor belts, one using covering material and one using salt. At the Sigmundshall site, we're not operating that much, so we can use the same conveyor belt at the same time, but see it as a heap growing into one direction, having other directions open to covering.
Okay, very good. To all of our attendees, we are coming up on the end of our time today. Nevertheless, if you have questions for the representatives from K+S or Josephus from NineSigma, please feel free to continue submitting your questions. As I said at the start of the Q&A session, if we don't get to your questions, don't worry, we'll include them with the Q&A transcript of today's webinar, so you will get the information that you're looking for. With that in mind, we'll go ahead and proceed to our next question. Can you elaborate more on the issues and challenges associated with the thin layer covering technology that you had mentioned previously and the evaporation covers? I think they're looking for other issues that you've encountered with that and why that's not a viable solution for all of your sites and processes.
So we're applying the thin layer cover, like I just said, at the Sigmundshall site with a certain material which is used from aluminum recycling. So it's leftover material or waste material from aluminum recycling, which can be applied for this cover, because you need a certain fraction within the material. You need to create these slopes, and this material is actually suitable for this covering technique. But the problem at this site is that we don't have enough material available to cover a second tailings pile with the exact same material. And that's why at the Werra site right now we're developing a new covering material to apply the same technique, but with a different material. And in this case, it will be slags from waste incineration combined with ashes from coal combustion, which generates a possible thin layer cover. And that's basically what we're looking at. We need to have the exact same, or at least close to the angle, slope angle that the material can stick to. So the covering material needs to fall the same way as the salt, to say it not so professional, and it needs to stick to Also, the stability is a big issue. It needs to be stable also in the long term. And plants need to grow on that because in this case, we want an evaporative cover using plants to reduce the amount of brine forming by evapotranspiration. And so there's several issues that you have to consider.
Okay. We have our next question. Well, this is a very particular question. What is the particle size of the tailings at their surface?
The particle size of the tailings, that depends, because we're heaping up salt, which is rather sandy material, but at the same time, as soon as it rains, the particles will stick together. But when heaping up, we're talking about a size of 1 to 2 millimeters. But if you have it on the tailings pile, you have one rain, it will stick together and it will form basically one solid mantle structure.
Okay. Our next question. Okay, so this one is a slightly longer question, so bear with me as I read it. Brine has recently been shown to have promising capacity for carbon sequestration. If you were able to achieve the 80% reduction in brine, would you then consider processing it for industrial use? Because at that lower volume, it may have an economic or environmental value. So in short, would you consider a technology that after you got to 80% would allow for the brine to be used for an industrial purpose?
Usually that's not really an option, because to say it a little bit short, if it was possible to use any of the brine solution, we would do it we'll already be doing it by now, even for fractions of or only a few amounts. But we don't see any use for the material, because at the same time we have different salts in there. It's not sodium chloride, and it's the same problem we have with generating any other products with it. It's not clean enough to use it for anything. But we're open to all suggestions, of course, in case you see any solutions for that, and we'll check that, of course.
Okay, and actually our next question kind of builds off on a little bit of that. You were covering some of the composition of the brine. Is the brine composition constant?
Pretty much. If you would look at small fractions at certain sites, it would certainly vary a little, because depending on the age of the area where the rain falls, certain salts might be already washed out more or less, or to a different degree than on newer parts of the tailings pile. But usually we collect the brines all together, and since we have older parts and newer parts added, there's not really a big change in that.
Okay, very good. Okay, our next question: how often and how large are typical holes in the tailings? How often are they formed and how large are they?
So usually we don't see any forming of holes if we don't have any constructions on there. So if you just look at the pure salt, it will be really even. So because the rain will get at all the sides more or less at the same time. You don't have the forming of any craters or holes usually if it's not covered, or if there are no buildings constructed, or any non-salt constructions on the heap. So the solving is very evenly.
Okay, we are starting to notice a slowdown in some of the questions. For our attendees, if you think of a question outside of today's webinar, don't worry. I'll have some information on upcoming slides on how you can get answers to that. With that in mind, I'll proceed to our next question. We have, I think, just 2 left at this moment. Our next question: what is the brine volume that is discharged daily, and is that amount constant?
Well, the amount that is formed is really constant, but the amount that is discharged into the river is not constant, because that depends on how much water is actually in the river. We have a certain level of salt that we are allowed to put in the river, and therefore it depends on how much water you have in the river. So the discharge is not constant, but the forming is constant, and that's why we have these large storage ponds in case we have droughts or have small amounts of water. So the forming is really constant, but the discharge depends on the water within the river Werra.
Okay. Our next, and I think possibly our last question for today, is a solution that modifies the salt tailings at the end of the processing before it is sent to the pile acceptable?
That's a good question, because I can't say that in general if it's legally possible. It depends on how you treat it. But in general, I would say, of course, we are open to solutions modifying the salt, but it depends on if there are any legal restrictions, which would depend also on the solution itself. But of course, we're open to solutions like that.
Okay, we do have one more question that just came in, and Arne, you touched on this a little bit. Would it be possible for you to provide an estimate for the number of liters per day that of brine that is formed?
We have, like I said, I can give you the yearly amount again that is formed at the sites, and the exact numbers that we had at December 12th to December 31st of the last year, because that's when we always get our numbers. The total forming of brine solution over the year is 720,000 cubic meters for the Hattorf site and 900,000 cubic meters for the Wintershall site, which would be about 2,000 cubic meters a day, around about 2,000 cubic meters a day.
Okay, well, thank you all of our attendees for those really interesting and engaging questions. Thank you to the K+S team for providing the technical details in response. At this moment, we don't have any additional questions, so I'm going to go ahead and proceed with the next slide. Like I said previously, if you come up with a question outside of today's webinar, don't worry, we'll have some mechanisms for you to get that information that you're after. So, what can you do today? First off, you can visit the challenge website. The URL is posted on the page right now. While you're there, you can register with NineSites. I strongly suggest, as Joost Sennens did a little while ago, that you register with the site and complete your profile in advance. That will allow you to get access to the online response form, and you can begin working on your response and have it ready in advance of the submission deadline. Now, if you need assistance, where can you go? You can reach out to the NineSigma provider help desk via email and by phone. The contact information is there on the screen. The email address is phd@ninesigma.com. The PhD stands for Provider Help Desk. Likewise, you can give us a call at area code 216-283-3901. Once again, that phone number is area code 216-283-3901. Both of those mechanisms will enable you to get your questions to us. And if it's a process-related question, we may be able to provide an answer pretty quickly. If it's a technical question, we probably have to refer that over to the K+S team. Regardless of the nature of your question, we will get you the information that you're looking for. So if you have questions, please feel free to reach out to us and let us know, and we'll get you the information or assistance that you're after. Last, and perhaps most importantly, that submission deadline. The deadline for submissions is Wednesday, December 12th, 2018 at 5 p.m. Eastern Time in the US. As Joost mentioned, because we have that 5 p.m. deadline, you have to submit your proposal in advance of that deadline. We can't take any late submissions for this challenge. So if you're interested in submitting, take some time, register with NineSites. You can start looking at the online response form and formulating your response and putting together the information that you would like K+S to consider. At this time, that will conclude the webinar for today. To our panelists from K+S and from NineSigma, thank you, gentlemen, for your expertise and your information that you shared with our attendees today. For our attendees, thank you for listening. Thank you for your very interesting and engaging questions. We look forward to receiving your responses. Thank you all once again for joining us today. Have a very pleasant day, and we look forward to hearing from you soon. Thanks. Bye-bye.